Welcome back from the break. We're in the home stretch. I hope you are looking forward to this panel as much as I am. This is people trickling in. Welcome back. So I am pleased to introduce Professor Chiara Sabatti, who will be moderating this next panel on how to increase trust in data science. Chiara, as you saw earlier, is an associate director for Stanford Data Science. She's also the conference chair for this entire conference. So just a quick round of applause to Chiara. And welcome.
All right, so I think I'll sit here since we have. So thank you. I am, as you know, this panel, it's entitled How to Increase the Trust in Data Science. And I think the pandemic that came up already a number of times today has reminded us all the importance of having a healthy, trustworthy relationship between science and society. And really, it doesn't make sense to do any science if we cannot communicate it to society. It's not a solitary endeavor. And I'm very glad that we have four people here from the Stanford community who are going to help us think about this. I'm going to introduce them, and then I'm going to ask them to make some statement about what are their immediate reflections on the topic, of what in their work it's connected to the topic. And then I have some questions to start the conversation, but I really would like this very much to be an open floor type of discussion. So please think about your questions and do not be shy in asking them. So in the order here, we have Debra Satz, who is the Vernon, Lysbeth, Warren Anderson Dean of the School of Humanities and Science. She's a philosopher. She's a member of the American Academy of Art and Science, and she's the author of several books. The only one I'm ashamed to say I've read is Why Some Things Should Not Be for Sale. I recommend it strongly. It was very clear and helpful to me as I was trying to think about fairness questions. She is a wonderful dean to have. Deans have this, I think, terrible, for my point of view, job of having to say something in millions of different occasions and having to send out letters with cheerleading intention or not. And whenever Debra introduces or says things no matter what occasion, her remarks are always very informative. They get me excited about the job. So it's really a delight. I'm very happy that she's here. Then we have Professor James Zhou. He is an assistant professor of biomedical data science and by courtesy of computer science and electrical engineering. He's a recipient of the NSF career and a 2 times Chan Zuckerberg investigator. He is also a person I look up to, even if generationally he's much younger than me. He has really published in a vast array of topics in biomedicine. He's a member of my department, and he has also a number of publications in topics very related to this panel. For example, he has a paper that's titled Sex and Gender Analysis Improve Science and Engineering, or Word Embeddings Quantify 100 Years of Gender and Ethnic Stereotypes. So much to say. Professor David Donoho is the Anne and T. Robert Bass Professor in the Humanities and Science. He's a MacArthur Fellow, a member of the American Academy of Science and National Academy of Science. He has an infinite amount of honorary degrees and prizes. And he has a very strong experience both in research in academia, but also consulting and working with industry. He was quite literally one of my teachers, and without, I didn't love his lectures in the sense he wasn't the most structured teacher. We never knew if he was going to be there on a certain day or not. But with all respect to all the other wonderful teachers that I had during my first year here, I have to say David Donoho's lectures and remarks are the ones that I find myself going back more often. So he really had a fundamental influence on what I think, and I'll tell you two things that are related to today. One, there has been some rumoring around, well, statisticians are abstract, do you do really data analysis or not? Our first assignment for David Donoho class was go and find some data. And those were dark ages of the internet, so there was this new thing called Netscape that has appeared. And so we were shipped out on the internet to go find data sets. So he is a data scientist at core. He also had this remarkable expression that, I don't hold him responsible if it sounds a little bit arrogant, but got me totally energized, telling us that as statisticians, we wear the ethical consciousness of science. So very much the data scientist and embedded with ethics. Sherri is an associate professor in health research and health policy at the Stanford School of Medicine. She is also a recipient of many awards, including the Gertrude Cox Award and the NIH Director's New Innovator Award. She has a very interesting background in that she has done some very strong methodological work on causal inference. Early during the day, we were asked, do you have the certification to work with observational data? And I think she definitely does. But she has also started thinking very strongly about policy implication of our data analysis. For example, one of the areas where she works is healthcare spending and insurance, and one of her latest papers is titled Fair Regression for Healthcare Spending. I have had less pleasure to interact with Sherri because she joined Stanford during the pandemic, so it's the first time that I get to meet her in person. But she has been very generous with her time, saying yes to a number of invitations that I had involved her with. So after all this talking, let me give them a chance to actually say some initial remarks about the topic of the panel and how they think about it. Debra, would you like to start?
Okay. All right. Well, thank you for having me, and I'm so excited and thrilled about this event and this bringing together data scientists, with social scientists, with humanists. I think the problems that we face are daunting, and we need many voices at the table. I was a math major, but I'm not as an undergrad, not as my field is philosophy, and I don't really work in the space of data science, but I'm gonna talk a little bit about trust in general and some lessons we know about what increases trust, and I think some of those will apply in the context of data science. So trust is a pretty complicated phenomenon. It's a relational phenomenon. It's not a one-way. For me to trust you, I actually make myself vulnerable to you. I take your word. I rely on you in my planning. When I trust institutions, I take their word, I rely on them, it influences my planning. So it's relational, and it's not always the case that trust is a good thing. It is very important, but if an actor is not trustworthy, right, it's rational not to trust them. So while lots of things go wrong when we don't have trust, sometimes it's appropriate not to have trust. Sometimes it's actually good for people to be skeptical because it makes them pay more attention. So I just want to point out it's not a singular good, but in lots of contexts, the absence of trust makes things go badly. And certainly the absence of actors that are trustworthy makes things go badly. And sometimes there's an interaction effect because when people don't trust you, so imagine around issues about data, or they're not trustworthy. If they're not trustworthy, of course, they'll do things that make people don't trust them so much. And if people don't trust them, they may withhold data or game data or manipulate data, which then feeds back into research is becoming less trustworthy. So what factors do we know are helpful in increasing trust and increasing the trustworthiness of actors? And I'll give a couple of factors that I think are pretty general. Some have to do with the input of what we're doing, some have to do with the output, and some have to do with the process. So on the input side, if you want trustworthy actors, they better be competent at what they're doing. You want people who actually are able to deliver. If you're, gathering data to help with some kind of problem, you want to make sure you're actually gathering the data correctly and the data that you need and figuring out what that is so the input matters, the competency of the people matter, the outputs really matter. And in particular, you want outputs that really deliver benefits to people. If your outputs are not helpful, if they're damaging or harmful to people, they're not going to trust you. Even if your intentions were very good, if you are not alert and not on board with thinking about the outcomes of what you're doing and the potential risks, right? People are going to not believe in you. You're not going to be a trustworthy actor. And sometimes in Silicon Valley, and our students and we say, like, move fast and break things, but if you break a lot of things and those things turned out to be really important to people, they're not going to be happy and they're going to withhold their trust, whatever your motives were. On the process side, there are a couple of things we know work well. Transparency is important. Transparency about what you're doing and why you're doing it, and if you're collecting certain kinds of data, why, and being very open about that. I think accountability is really important, that you're making credible commitments, and if you don't follow through, that you're actually accountable, and that people see that people who make, who misuse, right, data or are bad actors are actually held accountable. And then there are concerns about fairness in the procedures. And here, in terms of fairness, there are many conceptions of fairness and many dimensions of fairness, but I'll just say I think it's really important to make sure, particularly when you're using data to address problems, like many of our social problems that have differential effects, that you consult widely and you make sure that there are all the relevant voices at the table, and you pay special attention to the people who are most disadvantaged or have the potential of being most disadvantaged by what you're doing. So I think maybe I'll stop there. There's more to say, but.
Thank you. We are in this linear order, so.
Great, thank you. And if there's one takeaway from the panel is that if you get a chance to be introduced by Chiara, then it's definitely you should get her to introduce you. So I'm James. A lot of my work works on developing data science and algorithms, especially for healthcare applications. And especially when we're thinking about applying the data science insights and the methodologies and algorithms for dealing with patients and doctors, I think trust is especially important, or trust in the insights and also trust in the data. So I just want to give you one example to illustrate, right? So recently there's been a lot of interest in using basically computer vision to look at your skin as a test for skin cancer, right? So there are a lot of companies that are doing this. And if this works, it could be very valuable because skin cancer is often underdiagnosed, right? There are millions of people around the world who are not caught with skin cancer until it's too late. So it looks very promising. So we actually took 3 of the latest models including ones developed by very large companies. I won't name the company, but they funded many parts of campus here. And we just evaluate them on Stanford patients, right? So these models, if you just look at their original publications from their paper or from their press reports, right, so they will get very high performance, AUC or accuracy about 0.9. When we test them on Stanford patients, the performance, much to our surprise, is just barely above random, right? So the AUC is about 0.6. So this led us to, and we were quite surprised because these are like commercially available algorithms that are going through different parts of the FDA approval process. And we wanted to audit to see, okay, can we actually do a systematic audit to understand what are the factors that contributed to the algorithms doing so poorly on the real patients here at Stanford. And after the audit, what we learned is that most of these drop-offs, algorithms performance, most of the mistakes they were making can be attributed back to the training data that was used to train the algorithms. Right? So it actually turned out that the data that we used to report the very high 0.95 original AUC, they had a lot of mistakes in them, right? Just simply there are annotation mistakes in that data. And secondly, the original data basically had no images from dark-skinned individuals, right? So that the algorithm had very disparate performance when they were applied across different skin tones. So there are factors like those that I think are really important to understand, right? So the lesson that we learned from this is that oftentimes, the performance of a model or algorithm or data science model is really meaningless unless we really understand more deeply about what is actually the data and the data pipeline process that went into behind developing and evaluating this model. And this also highlights, I think, sort of maybe one limitation currently in a lot of our education and research, right? In many of our classes or when we do research, oftentimes we're given a particular data set, right? The data set is given, and then we teach students how to build really good models on top of that data set, right? That's how most of our classes are done. Right? But in practice, in industry, right, the biggest challenge is often how do you actually come up and create the data set in the first place, right? And there are many challenges there, right? So for example, how do you decide what are the most informative data points to collect, right? So there are active learning questions there. Given some data sets, right, oftentimes now it's also unstructured data like images and text, how do you figure out how to efficiently annotate the data, right, to reduce these potential biases, right? So annotation can be challenging. And now, if you have a collected data set, oftentimes it's noisy, right? How do you systematically clean the data set? And after you have cleaned the data sets, what are the systematic approaches for even evaluating the data set for potential biases, like the ones that I mentioned? Right, so each step of this pipeline corresponds to and raises a set of really interesting technical challenges and also sociological challenges that I think requires a lot more research and a lot more emphasis in terms of the education that we do. So a lot of my work that my students work on are very much focused on looking at each of these sort of data-centric challenges. We're trying to come up with some combination of new methods, scalable algorithms, as well as collaborations with people like in history and in other departments for looking at these problems. And I think as we're thinking about how to build more trustworthy data sets, right, and more trustworthy data science applications, then I think really it's really important to understand each of these components of the data creation pipeline.
Chiara, thank you for the introduction. The number one thing that occurs to me is how difficult it is to really reach a conclusion from data, and the struggle that many people have when they get started in the data analysis business with doing anything right. It's a long, long time between when you first know a little bit about coding and you do something with the data set that really strikes you as having gotten to the heart of it and it must be right, and you think about it a lot afterwards and you realize, yes, I really got to it. In between those 2 points, there's generally a lot of personal development and struggle, which can last for years and years. I think that this may not be the first thing that we tell master's students in data science, but it's maybe the most essential lesson. And the development of data acumen, mastery, things like this are a big part of the journey towards understanding how you can learn something from a data set and how you can feel that you got it right. Now, there are many steps in this process, but I thought I would just share one set of tools that theorists have, and then one set of tools that non-theorists have. So as theorists, we generally develop generative models, and we say, okay, if the data were generated in such and such a way, would that produce what we're actually seeing in real data? And that has been around for, I'd say, 350 years as an approach, and it's been very successful. I think data science and statistics is basically that subject, but there are other subjects that definitely use that approach. Data science took a different route as an industrial job categorization, which is there is only data. There are no true models. There is no generative model. There is only the workflow, and we build workflows, and we do stuff to data, and then we show you what we've done. The thing that generative models give you is an approach for academic discussion, because people can learn what the generative rules are, and they can understand whether the generative rules produce data with the particular structures and artifacts that you're seeing. The other approach, which is end-to-end workflows built, for example, in an industrial setting, they don't have anything underlying them other than the data set, which you often don't get to see. How can you develop any understanding of what the data are offering and what the message is in this second setting? So one thing that has helped me, and I've seen it help other people, for example, in consulting projects with the Wigler Lab at Cold Spring Harbor, is let's think of a three-way array: data sets across methods, across observables. And we're going to just endlessly make we're going to make essentially scatter plots across all three dimensions and see how any pattern we're interested in changes with the data set or with the method or with some particular way of coming up with an observable. And I think that is one of the most potent tools that people who are operating in this end-to-end workflow arena have. And perhaps this is obvious, but it brings up a point, which is depending on what it is, the underlying computation, let's say it's a deep learning model, there could be a great number of individual computations that have to be done underlying that. Many trainings of models, many variations of architectures, et cetera, et cetera. And so the only way to carry out this kind of comprehensive XYZ gridding of your understanding of how to tease apart everything that could affect the analysis is to have pretty massive resources. So the generative model approach that was prevalent because of the mathematical sciences, probability, and statistics, you had to have IQ points. Now you need to have a dollar budget. And I think science funding hasn't really caught up to that. So I would say that we need a very extensive rethink of how science funding is being handled so that there are adequate resources. I was really happy to hear that there's interest on or work, I don't know the status of it, on building up a compute cluster or other compute resources associated with this center. I think national level facilities and totally new science funding has got to be thought through and developed. So once that's done, it'll be much easier for people to find the resources to do the kind of computations that are needed to pull things apart across multiple varying factors. If not, what happens is people become advocates for one model, or they become advocates for one data set or one particular observable, and it's actually that their hands are tied behind their back and they're just making a stab in the dark. So the trust that we can have on something that's been really exhaustively computed would be, I think, a big improvement in many people's ability to trust research. Of course, for us to trust other people's research, we have to be able to use this, which could be called a kind of recompute approach on other people's data. So they have to publish it. It has to be understandable to us. And then we have to have the resources. Beyond funding, there's also just the resources to make this kind of computing easy and almost irresistible. And I think there's been a lot of progress recently in the ML ops startup community, but that also is going to lead to voracious demand for funds on the part of researchers who want to use all those fancy new ML ops tools.
This is my first in-person conference in over 2 years, so I hope I remember how to do this. I'm a statistician by training. I think I'm not supposed to mention that I did my PhD at Berkeley, but Sandrina's here, so at least one person's happy about that. But I'm also equally a health services researcher, and so a lot of my comments will be related to the deep integration that I have with problems in health policy. So when we think about trust in data science, there are many things that I aim to incorporate in my work. One thing that we should be thinking about is who is doing the work, who has access to the data and the resources, who has the power or political capital to be making decisions about the types of questions that we ask and answer. Another one is who is being cited and who is not being cited. We've seen examples where certain fields of work within data science are less valued and have been led by people of color and women. And over time, as those areas become more and more valued, that foundational work is not cited and recognized. And so there are initiatives like Cite Black Women, led by Kristen Stewart, to draw attention to many of these issues. Another question is, what is the goal of the work? I mentioned that I'm equally a statistician and a health policy researcher. The goal of the work that I'm doing is to try and develop methodology that solves real problems. And I think one of the things we need to think about with trust in data science is being good stewards of the data. So if the goal of the work is to solve a real problem, that would not involve treating the data like a toy problem, which is also related to another point of mine, which is genuine integration in the application area. So when you start chasing things like my goal is an 8-page NeurIPS paper, my goal is a 6-page JAMA paper, that's not the same goal as trying to solve a real problem in healthcare, which is the area that I work in, and it's not necessarily being a good steward of the data, although it could be. Another thing that dovetails nicely with a number of the other comments on the panel is more comprehensive evaluation of the work that we do, broader sets of metrics, not just things beyond AUC and overall fit metrics, but metrics for marginalized groups. And then also thinking deeply about generalizability. So much of the work that we do might be in a single data set or a single year of data in a particular medical center, and making any broad claims about this algorithm or tool should be used in practice could be pretty dicey, especially if we haven't looked at external samples. And some of this leads to us having minimum standards for this type of work, especially in healthcare, and we've seen a number of papers and guidelines that have come out. I myself have worked on some, including a recent paper led by Irene Chen, who's a PhD student at MIT, where we developed an ethical pipeline for machine learning in healthcare. There's also a recent paper by Judy Gachoya at Emory about operationalizing fairness, and these are all important endeavors. But I think one of the places we need to go to as far as trust in data science in the health space is enforcement and having some enforcement mechanism that comes down from funders or journals. We've seen how this has been really useful in the past, especially for things like pre-registration of primary outcomes in clinical trials, because right now the uptake and the engagement with a lot of these guidelines and recommendations is pretty weak. And so I would love to see us move in that direction. And I'll stop there.
Well, thank you all. So I do want to do you have questions? I have some questions prepared, but I don't want to. I've already spent a lot of time introducing the panelists. So if you have questions, raise your hand so I know that you have questions and I don't ask useless ones. But I wanted to go back to the issue of privacy and sharing of data, sharing of methods that a couple of you mentioned, but also it was mentioned during the rest of the conference today. And, you know, it seems that for the point of view of who does the data analysis, the more data, the better. But, you know, the data belongs originally to somebody, or it's relative to one person, and there are sort of then concerns about privacy. Do we really want to know everything about everybody? So there might be a trade-off between privacy and large data sets available that would make easier to extract knowledge from them. And I wonder if you have any thoughts about this trade-off, if there's a way of mitigating the trade-off. I don't know, James, do you want to start?
Sure, happy to take a first stab at it. I think this is definitely a very important topic. It's like one example that comes to mind is that you know, many of us here have been using this resource called the UK Biobank, right, which is a place where 500,000 people in the UK have actually consented to have their data being used for all sorts of medical applications. But once in a while, like maybe every couple of weeks, I'll get an email from the UK Biobank that says, person X has decided to withdraw their data from the biobank. If that happens, then you have to delete their data and also delete their data from any models being used, trained on that data. So this actually raises a really interesting perspective that's different from privacy, but I think it's perhaps even broader, which is that these individuals, and like many individuals like us, we have consented for our data to be used for certain applications, right, when we over some time period. But the individuals also like to have control and some sort of governance, right, ownership even, that says that if they, at a later time, they can decide to flip off the switch and say, my data can no longer be used for these applications, right? So here it's interesting because the people have certainly given away their privacy because these are genetics data, medical records, but they still want to retain this level of control over when and how the data can be used for specific applications, right? And this, I think it's worth maybe even taking the discussion beyond this traditional notion of privacy and going to this more question about data governance, right? So how do we enable individuals more options or control over when and how the data can be used? And this leads to a lot of really interesting, I think, open challenges, right? For example, like even if when you decide to delete your Facebook account or delete your Twitter account, the algorithms that are used by these companies actually still retains a lot of information from your data, right? So it's actually not obvious how do you really remove your data from these large models after the models have been trained on this data, right? So that again goes back to the question about how do we really give individuals more ownership and more agency over how their data is being used.
Can I? So I think that's really important, and I'm with you, and I think the questions you're identifying are really interesting. I wouldn't want the default to be that every individual owns their own data, because there are also problems with that assumption. We have some strong reasons, like I give the example of COVID. We don't want people to be able to remove data about how many people have been infected in an area. So if you think of it as it's the individual's right, then the individual can pull that out. And so I think there's a governance question and there's a democratic question for us together to think about what kinds of data should be private, and there clearly are reasons to hold some data at the individual level, and what kinds of data actually you don't have a private property right over, because there are important public goals that couldn't be met if you held that data back.
Just from the statistical perspective, self-selected data is very problematic. And maybe self-selected erasure is also problematic in some ways, so that it might jeopardize the whole project if there were a wave of people who, due to herding, all had certain characteristics and took themselves out of the data set.
I was going to raise exactly this question, but maybe we can take it a step further, which is, most data sets probably have some kind of selection bias, right? And we know that selection bias can really screw up any type of causal inference you want to make from a data set. So how do we, I don't know, maybe James, since you've thought about, these issues about sort of distributional shift and stuff like that, or Sherri, you may have thought about this as well. I don't know if, are there ways to think about, particularly about selection bias in the context of fairness and trust?
I can start. So the representativeness of the data and the selection bias involved in which data that we see and who's part of the data is a really important question with many facets, and I'll just touch on a couple. But for example, I've worked with both randomized trial data and observational data. We know that randomized trials are often held up as a gold standard, but they have many of these same selection issues. For example, if we have a randomized trial for a particular type of cancer and 20% of the population that has this cancer is Black or African American, and we see that the randomized trial, only 2% of enrollees in that trial are Black or African American, we know that we have a substantial issue. And in our observational data, James also brought this up, we rely on who's in our observational data sets. And the data that I work with is many of these data sets, who has an encounter with the healthcare system. And many individuals, including people from low SES backgrounds, for example, are not going to have an encounter with the healthcare system, or individuals who do not currently have health insurance. So many marginalized individuals will not be included. And so I do work in generalizability and transportability methods. Some of these are complex, machine learning, double robust, all that jazz, but they can't really take the place of a deep understanding of the exclusion of marginalized groups, and as well as remedies to this systematic exclusion. So a lot of these tools just really, it has to be both, not or.
And maybe I really like that point, and just to follow up on Sherri's points a bit more, is that, so I think exactly a lot of the clinical, even the randomized studies, even though that's sort of the gold standard from the causal inference perspective, there's an even stronger selection bias for them. Like a lot of the clinical trials are really looking for the Olympic athletes of the patients, right? And it's actually now well appreciated that the causal effects identified from the clinical trials often do not translate when the drugs come on the market for the average non-Olympic athletes. And there, I think some of the most exciting efforts are being really large efforts to curate much larger, more representative data sets. Like, for example, the Flatiron Health Network is one example where they're actually going around to over 280 community cancer clinics to actually get more data from those community clinics to get more representative populations, which are very different from the ones that are participating in the clinical trials. And there, that runs into all sorts of these, the data creation questions, like how do you harmonize data from all these different clinics? How do you fill in the missing data, and how do you extract the data from the medical records? But I think that's sort of where a lot of the most exciting work is happening.
I wanted to ask, sort of take off from where Dr. Satz made a really important observation right at the start, which is trust is relational. There's no such thing really as a data set that you trust. People, there's a person who is trusted, who's making statements on the basis of their research, and there's people who are doing the trusting. So I think to answer this question, we have to be really, really careful about how we define both. So for example, with what example Sherri was making about the conclusions from a clinical trial that's not representative, if the person who is publishing that says, this is not generalizable because my population did not include these minority groups, that's a perfectly reasonable statement. The issue is, how do we trust the statements that are made on the basis of the analysis, and who are we trying to convince? If we're trying to convince a fellow scientist, a lot of the conversation had to do with, how could I convince a fellow scientist that it was true? It was substituting truth for trust. There are lots of things that are true that people don't trust, and a lot of things that are untrue that people do trust, like the effect of ivermectin and hydrochloroquine for COVID, even though they don't trust the actual actual RCT findings. So I think we have to be very, very precise about who these two agents are. If we're trying to convince a doctor and we're a data scientist or whatever, that's a certain set of tools to get a doctor to be convinced enough to treat a patient. And we have a whole set of norms, some of which are not very good at that. I do think transparency has a lot to do with that, and there's lots of things about how consensus is formed. If we're trying to get the general public to trust the science establishment, then we have a whole different set of tools and a whole different set of answers, of issues, which do get to issues of transparency and democracy and who's participating and who are other people who can see the data. So I think this is a very layered and nuanced issue of who are making the statements on the basis of the data, and how are those statements processed, and who do we want to be trusting them. And it can be a completely different answer if we're saying a physicist trusting a fellow physicist, or a person who's driving a car trusting the engineers, the doctor trusting the authors of the paper, or the general public trusting. So I think we need to address each of them, and in this community of scientists, we often think that if it's more likely to be true, it's that trustworthy is more likely to be true. But I think if we're talking about trust, we're going to have to enlarge the conversation to include all the complexities that Dr. Satz, I think, started this with. Thank you.
Thank you.
Somebody over there.
Oh, hi. My question, I think this is a really fascinating discussion kind of about privacy and trust. I think a growing body of research is around the use of simulated data that might have different privacy guarantees. And I think it follows the previous question about kind of who the trusting body is, because I think, privacy guarantees can help, the trust of people who might be opting into the study, or, for example, in the US Census, this current one kind of has differential privacy guarantees in terms of kind of simulating the census data set. But on the other hand, you might have less trust in downstream findings, given that we might not know the generating function for, the simulated data set. Like, how do you think we as scientists should balance, the privacy and trust, especially, when we don't have the full information of maybe how data is generated?
If I might join your two comments and question, we talked about data because at the basis of data science there is data, and we try to describe some characteristic of data that might play a role in this trusting. But if we think about the general public trusting data scientists, we have many settings where the general public trusts people. They trust the doctors, they trust the engineers. And generally, these professions that need to be trusted by the public, often they have an accreditation protocol. They have people in this profession pledge to follow certain norms. So maybe we can phrase the question in terms of, are there some ethical conducts for data scientists, something that we should pledge to follow so that we can be, and are there some accreditation criteria that could facilitate the public trusting what we do?
You're looking at me.
Anybody?
I'll just say, I think it's a great question. Professional norms do seem to make some difference both in behavior. They're not not merely symbolic. I think we have an educational responsibility in the way we're training the next generation of our data scientists. This goes back to what you were saying about, we want to think about the construction of the data sets that we're working on. I actually think we want to think about the outcomes that we're aiming at. We want to think about trade-offs. We want to think about the different values. I think there's also a huge issue around uncertainty and how we communicate about uncertainty, because that's a very important factor in trust. But we need to say when we don't know and when things are uncertain, but there's also a tendency when you indicate a lot of uncertainty for the public to feel less trust. And so there's but we've got to get a new generation thinking about these issues in the very training of what it means to be a data scientist.
Anybody else? Otherwise, I think we are out of time already, no? Are you keeping track?
I have a question.
Please.
Yeah. So in terms of data science training, I find that actually there is a tension between some traditional method, especially respect to basic chemical or physical principles, and also some new data science method, like machine learning method. And when talk about a specific task, let's give a concrete example. For example, to predict air pollution levels at Stanford campus, I can use the chemical transport models or a machine learning model from satellite data. And the two groups of people won't trust each other's results in terms of, for example, machine learning models have a higher R-square evaluation measures, but the chemical transport models have a clear physical principles behind that. And especially, for example, in these chemistry groups, they actually trust other chemistry or physicists more than data scientists. So I would see, in terms of training, how this thing can be harmonized in the future.
Anyone?
So any idea on training? I think, there's two trainings. There's training of the data scientist, and then there's the training of everybody. Like if data science has such a big say, if it's in what in the journals tells or not, we all have to be able to interpret data to some level. We have a responsibility toward data literacy for everybody. So I don't know if.
So bilingualism helps. If you know how to do the scientifically motivated generative model of the phenomenon and understand how that affects your workflow, and if you also know how to take a given workflow and tweak its parameters and understand how those sort of data science operations affect your workflow, you're speaking both languages.
And in the examples that you were mentioning, what we're trying to push towards is more about using more rigorous evaluation and monitoring, because oftentimes it's hard to decide what model to trust more from first principles. So then that's why it's important to do more rigorous evaluations and also evaluation over time, monitoring of these systems.
Any concluding thoughts?
No.
No.
Can you hear me now?
Yeah.
Okay. I'm going to ask a question that's coming from a different perspective. I know the title of this panel had trust in the word. Trust to me makes me feel concerned. I think trust is important. I like the terms like accountability and standards of practice, because I think we should not just trust people, we should also hold them accountable and be critical about what's going on, self-critical, but also critical of others. But I'm going to ask a different question. Data science and the whole frontier that it's building is not being built in a vacuum. We live in a research culture that has been going on for a while. So can you give me your perspective on the current norms, the current accountability, the current practices that are going on in the research institution now that you would be concerned that might reproduce bad outcomes in the data science age? And what would you prioritize to try to change or keep the same to make data science more accountable and more transparent?
Well, I could say one thing, which is came up with, the reproducibility of data, like going and trying to reproduce data. I think we disincentivize that. It's actually why would you take somebody else's finding and redo it? You're not going to make your name for doing that. But I actually think that's a very important thing we should be doing more of. And null findings, which are also tend people not to care about, they're really important. And so somehow changing the recognition for the value of the reproducibility and the null findings, I think would be important.
Yeah, just to build on that, I think we disincentivize a lot of the things that we would say would support robust, accountable, high standards in data science. We reward many quickly published short papers. We don't reward open science in the way that we could, although that's slowly improving. We don't reward reproducibility. We don't reward the generalizability. So why get an external data set when you can publish it with just 1 year of data in a single medical center? And so I think there are a lot of things that we could do to improve this. I mean, it would be some of it would be pretty radical shifts, but I think starting with minimum standards for the type of work that we publish. And I work in healthcare, so I focus on minimum standards for data science and healthcare. I mean, there's so much work that is published that wouldn't be if we had some of these minimum standards.
So I just want to mention in the context of these comments, Stanford is actually part of a group that was just announced this last week called Helios, the Higher Education Leadership Initiative on Open Scholarship. And Mark and Persis signed on to Stanford becoming part of this, and I'm kind of sitting in for them as their representative. And the goal of that group is exactly what you're talking about, of basically working, there's 50-something universities and colleges working together to basically figure out how can we build incentives for people to do the kind of science that we want them to do and that they need to do, realizing that in many ways those incentives are not aligned. It's a group that's being run by the National Academy of Science and Engineering and Medicine. So there's certainly hope that some of these things will be moving. And if anybody's interested in sort of hearing more about that, feel free to reach out to me.
Okay, and I thank you all very much, but it was an interesting discussion, but we think we are 18 more minutes. Okay, so very good. No, we can have, well.
I see a bunch of hands.
Yes, there's plenty of hands here, so.
I just wanted to say, speaking to this issue, the group we have in the School of Medicine working on increasing reproducibility has a working group on creating a CV, a new CV for Stanford that makes more reproducible research and open practices more visible. Because we actually think, see if this is on, I actually think that we're the ones who promote each other. So if we as a community value these things, if they're visible in the CV, they will be rewarded. we say that they're not, that we don't reward them, but it's because they're invisible. So the goal of this project, and maybe it will be subsumed under other things that are going on with Helios, is to be able to have the faculty show what they're doing in this area, so it can be valued in promotions committees. So this is particularly for Dr. Satz. So hopefully that will have some salutary effects, but it may also, we'll see what's going on with this consortium. Maybe they're doing the same thing. And anybody who wants to contribute to that, please contact me, Steve Goodman.
Yeah, I just had a quick question about like a different kind of trust. So all of you do interesting like interdisciplinary data science work. So on teams, when you do research, as we talk about drawing in experts from different disciplines, how do you build trust in the team when people speak different languages? Especially in contexts where you might be interacting with an expert who you really value their expertise, but they're skeptical of an approach to science that focuses on quantification, which is an experience I've had a lot meeting people who work on qualitative research who have really valuable things, but I think are skeptical of data scientists who are interested sometimes for that reason. How do you build trust on teams in that?
Great question. I'll say one thing which we've found pretty successful in terms of an ethics initiative that's been going on partly around artificial intelligence, but where we're embedding ethicists in groups. So it's not like somebody coming from outside and speaking a language and pronouncing from on high, like we've got the answer here, but actually working together over a long period of time in order to learn more about each other's languages and then be able to contribute in more positive and helpful ways.
Yeah, and I think these long-term collaborations, like you mentioned, are really important. I think one of the best ways to build trust over a diverse team is to really bring them in from the very beginning, right? From the, not just at the very end in the paper writing and the validation stage, but think about even in the question formation stage, right? So some of the most fruitful and fun projects that I've had the pleasure to work on involve collaboration with historians and linguists here at Stanford, and we started those projects from the very beginning, and even in conceptualizing what to do was, what to do, what questions to ask.
Hello. Hey, just had a question for, I guess as everyone could, and feel free to answer. So I had a question about, so could you describe a scenario or example where getting comprehensive, trustworthy data is really, really hard, but really, really important? And could you also describe like how do you address that problem?
Well, so I work in genetics, and it's hard to get good genetic information for people with different ethnic backgrounds. And not only it's difficult to get good genetic information, it's difficult to get access to phenotypic medical information. It's much easier, you can imagine, to get information for people in the United States that it's to get from people in Central Africa. The medical resources that are available there are just not comparable. So to say, oh, I want to design a study that has population from all over the globe, it's very challenging. At the same time, it's very important because the environmental factors that people are exposed across the globe are diverse. Our fundamental biology is the same, but there are differences in our makeup, in our genetics, just due to evolution over time, the randomness of how some genes get transmitted or not, some mutations arise or not, and those ones might have implications on how well you respond to a treatment or not. So a big challenge, for example, in the studies of genetics is how do you get data on a diverse set of people? And you can collect some diverse individuals in the United States, but really that doesn't represent the geographical diversity, the different type of exposures and culture that people have all over the globe. And it's challenging, and it's a clear challenge in terms of resources, but still quite important.
Hello. Yes, it works. Yeah. Hi. Thank you so much for this panel. A question that I have that I would like to hear your thoughts on is sort of the promises of data science have been sort of the scalability and the efficiency, which at the same time is also maybe part of the reason why it's seen as sort of the fast, sloppy, superficial way of doing things. I recently attended a conference about learning analytics where there is like lots of fine-grained data. And at the same time, people were identifying the problem that this type of research doesn't really happen in communities. So there's lots of data, but people aren't really within communities of learners to understand where their problems might arise. And I wonder to what extent the issue of trust is because there is a lot of unknowns for the people that data are sort of extracted from. And so I wonder how you feel about sort of the approach of there might be more room for mixed methods, because I feel like there's this really hard part where it's really hard to combine sort of the promises of data science with that exact issue of that you're so far removed if you're just simply working with data from the population that you care about.
I absolutely agree that we need to, for example, involve in data science, impacted communities and incorporate qualitative information and community-based participatory research to understand, to make sure that the work that we do in data science, especially when we're thinking about having more complete data sets, is particularly not extractive. And we also need to be open to the idea that there are some questions that we shouldn't ask and answer, because if you're going to engage in this process, that you need to be open to that. And that there's some information that maybe you might want to collect, and you have to be open to the idea that maybe we don't collect this information because it can be stigmatizing or harmful or perceived that way, and that would lead to individuals not wanting to share their data. So I think there's a great need and a lot of promise for having mixed methods and bringing together these fields with data science, for sure.
So I want to bring back a concept that was touched upon before, that is the role of uncertainty and variability. So, we have said multiple times now that trust is a relational quality, so you need to have two agents talking to each other. And I think that people cannot trust each other if they cannot understand each other. And when we think about scientists trying to communicate their results to the general public, I think we have a longer, more serious effort to make than when we are communicating to other scientists. So, how do we communicate the nuance and the complexity of our finding? Because science often doesn't have a yes/no answer. Whatever effect we might have comes with lots of cautions. We have, things like confidence intervals or prediction intervals in statistics. But what strategies have you found are maybe more important to pursue, more successful in communicating the complexity of the scientific finding to the public?
Yeah, I think that's a really good question. One technique strategy we found to be very useful is to have more interactive interfaces between the data science and the models built from the data and the end users, which could be public or could be domain experts, right? So, for example, we try to build these interactive interfaces where the user, maybe just on their web browser, right, they can just say, they can change the data. They can say, what happens if I remove this part of the data, right? And then see in real time, how does that actually affect the predictions and also the uncertainty that the model makes on the data, right? Oftentimes, it's hard to describe those, just hard to get those just from reading a paper, right? So if you can actually interact directly with the data and then tinker with it, oftentimes you get the users get much more better sense of what is going on with the model and with the data, and they can develop more trust.
I have one. I actually think, maybe I'll be speaking to the choir here, we should be teaching statistics earlier. It shouldn't be that you have to wait to college to get statistics. We actually should be teaching it like in junior high school and high school. We should be helping kids understand concepts like risk and uncertainty. We've got to do a lot more. I don't think we can just do it alone. We've got to have a national movement to really raise the literacy and the comfort of people with things like uncertainty and risk. And
I would endorse that and also stress that I think the AP statistics needs to be very heavily revamped. I dropped AP statistics and ultimately went on to major in it. That's how non-engaging AP statistics is, and so I think it, with this eye towards understanding uncertainty, et cetera, rather than reading tables in the back of a book and looking up z-scores.
Here.
Hello, is it on?
Yes.
Okay. I was wondering if the panel had reflections on the impact of the COVID-19 pandemic and the pandemic response on public trust in data science, especially as it relates to healthcare, since we have a number of experts on the panel.
Do you want to take?
Sure, I'll take a first stab at this one. I think the reaction to this is mixed. I think the pandemic has shown some people how advantageous collecting data and analyzing data in real time, how useful that can be for public health. I think because we saw some bad projections and predictions and some bad data science in COVID, it's also decreased trust among others. And so we're dealing with this bifurcation of how people are viewing data science, and we really do have a problem where some people think, oh, you can just make anything up with data. And we do need to surmount that.
Yeah, and I agree with that, and also I think it really highlights a lot of the challenges with doing good data science, right? And brought to the forefront that these are very difficult problems to make sense of the data, and different people can, reach very different conclusions and different projections on the same data set.
Are there lessons to take in going forward? Maybe it's too early to tell.
Well, I think, rephrasing somewhat all the questions, how does this compare with, how does this relate to another topic that emerged before of, do we make every data public? How quickly do we publicize our results? Do we have to put some control on when is some information ready for spreading or not? Some of the controversy around the pandemic was entirely political, and I think that as data scientists, there's nothing you can do if you have a divided audience that is going to fight about anything. Mm-hmm. They're going to fight. But, we had some problems with preprints. Research work that is not peer-reviewed, is not really a product of science entirely, but in a context of the pandemic, you want to shortcuts. You don't want to say, oh, there's important information there, and I sit around and wait for everybody to review or not. And then, we also discovered the peer review is not perfect, but it's useful because things that are not peer-reviewed are not peer-reviewed. And at the same time, you can put out data and people can torture it to make it say whatever they want. And so does the panel have any idea about what control steps should we or shouldn't not put in place in terms of data sharing and also research results sharing?
I think one important takeaway that, even really well-intentioned analyses during the pandemic were sometimes not very transparent, and people were trying to back calculate the assumptions that were made in the model to try to understand why they got such disparate results. And that's something that we can really take towards minimum standards. We've seen machine learning-based papers published in high-profile clinical journals where the algorithm is not transparently included, not in the appendix, there's no code shared, and part of that is because they might want to spin off a startup company. But how can we allow something that's going into some of our top clinical journals that they want to influence practice and have uptake and not be transparent about the algorithm? So I think that's just one example of something that we've learned is incredibly important, and I hope we can bring it to our minimum standards, that we transparently share the different features of what the model is.
I read a paper, I think it was by John Ioannidis and co-authors. There was a huge flood of papers due to COVID-19, like an incredible flourishing of scientific endeavor. 1 million papers, 2 million papers, I don't remember the number. And I don't know that the fraction of doubtful claims is any different in that flood of papers than what came before. Maybe it's higher because people are rushing, but it's just a huge volume of things. But people's anxiety about scientific mistakes was much greater because it seemed that the stakes were so high. And so definitely it was received into a different world, and also because of the emergence of medRxiv and rapid publication. That literally started just before the pandemic. So we were like utterly in a new world for clinical science publishing. And maybe we perceive that it's a world with flaws, but it might be quite continuous with what came before. I'm not sure.
This is not completely on this, but it goes back to your question about should there be like a code of conduct, or we're talking about, it does seem to me, so we have conflict of interest rules. We also have in the sciences where you've got to list all the people who are supporting your work. I don't know if there's any norm like that for data science, but that might be like a good norm, is if your research is being funded by, X and Y group, at least that people know that. And I definitely think we should make, when we can, the data we're using and the hypotheses, we should put them out before we do our work so that they're then available for people to replicate.
Yeah, and I think that's really important. And there's some recent efforts along those lines to make it more standardized in terms of reporting the entire life cycle of the data. So not just what's the final data that's being used, but also how the data is pre-processed and curated and cleaned even before that usage. And those are all really important.
And, to bring this back to uncertainty and to what Professor Donoho was saying, maybe we made some mistakes during the pandemic, but maybe they are just the normal amount of mistakes that the scientific process entails. It's not that every paper is right out all the time. We always have contradictions. So we have to find a way of going from scientific community to public consumption that I think needs to be rethought a little bit. We have to have the people comfortable with the fact that not everything is going to be perfectly spot on from the very beginning. There is last question. Do you have your mic?
I'll just make one. To be fair, I do believe there are people who make money off of playing against science and who have podcasts with millions of listeners and promote anti-science skepticism. And that also didn't exist 2 years ago. So that creates a whole nother layer of issue that we might not have had in the past.
And maybe they buy a lot of bots.
I'm afraid to make this the last question, but coming back to different versions of trust, there's the competence version of trust, but there's also the question of whether people are harmed, and underrepresented groups often aren't getting too much of a say in some of the questions that are being asked, and there are very diverse groups that might look differently at different questions, and we've talked about the COVID example. It's exciting that data science is moving into the policy and social sciences realm. Those of us who were in this business a generation ago would be very excited to see this, and it wasn't so much the way it was taught. What questions do the panel feel should not be asked? Sherri suggested earlier that certain questions, are not necessarily exactly pro-social. Mm-hmm. Do we have any clarity on what is science that should not be done, and how do we reconcile that, with our desire to sort of live in a world free of bias, mm-hmm. that we're going to just not ask certain questions? So, do people have thoughts about where data science shouldn't play?
Anyone?
So I think you've highlighted a really interesting trade-off, which is that there are certain types of data where it's relatively hard for us to collect, especially data related to sensitive attributes, right? And there are kinds of analysis that relates to sensitive attributes that are usually people would like not rather to do that, right? But on the other hand, if we want to evaluate equality or the performance of a given model across, to make sure that it actually works well across diverse populations, then we do need to have some of these sensitive attributes collected, or at least proxies of those attributes, in order to actually assess how well does the model work across these different populations. Right? So that's actually, I think, a really hard trade-off. There are different approaches for trying to address that, maybe by using proxies, but I think that's sort of a fundamental trade-off.
I interpreted your question differently. In terms of which scientific question we should ask and which scientific question we should not. And I think, and there is a trade-off between what you want to do, scientists to be as creative as possible and think about problems that we have not thought about yet, versus, is this a worthy questions for us to spend money on as a society? So I think, maybe scientists are free to run wild and ask any questions. But I would think strongly, if I were a funding agency, which research projects I fund versus not. And I think it's a real question. In genetics, for example, we often do the genetics. There's many studies that look at, can I find the genetic basis of educational attainment? Or can I find the genetic basis of sexual orientation? And I think you have to ask yourself, why are you doing this? There's certainly something to learn, but what are the repercussions of you just putting out a paper that says there are genetic bases for how well you do it in school or not? So I think if you ask some difficult questions or some questions that can have repercussions that are not what you intended to, you should spend a little bit more time. And you should do that in a context of a very carefully curated study. So I think these questions are particularly dangerously taken on when you use some recycled data, saying, oh, by the way, I have all of this data set, and I can also address this. And maybe it's not the best data set, but then you have these conclusions out there. But I don't know which questions we should ask or not, but I think it's a democracy type. It's a public discourse of what do we find, what do we support versus what we don't.
A related topic to this is there's been a lot more work now in trying to fix algorithms that have disparate impacts. And I think it's also important for us to, when we think about questions that are that we should be asking or shouldn't be asking, there's also that we should take a step back and say, instead of trying to fix this algorithm, should this algorithm exist? And that it's always valid to ask that. And sometimes the algorithm not having it will cause more harm than having it, but that's a question that's often not asked. It's really about, okay, can we add some variables or change the loss function, or how can we fix the algorithm? And there isn't that bigger picture of stepping back and saying, why does this exist, and should this exist, and is there another way to accomplish the goals that this algorithm was trying to achieve in a way that's more equitable?
All right, and on that, let's thank this panelist and
Thank you all. Thank the panelists. Thank you, Professor Sabatti, for that engaging conversation. Before we wrap up, I just want to take a moment to thank a few people who made today possible. Lynn Keel and Charlene Zelnis, who probably are not in the room because they've been working for weeks, if not months, taking care of all the logistics, getting great help from Stanford Events, Stanford Video, Stanford Catering, and the Huang facilities team. So thank you to them. Also, thank you to the volunteers who helped pitch in today, Heather and Joanna for the mic running, Janice, Pauline, and Judy, and Cassandra for the poster session, which is coming up. And of course, our data science scholars for the wonderful posters, their thoughtful work and design, and all the speakers who shared their vision for how data science is driving new discoveries.